Okay, thank you. Thanks for joining. Okay, let's go ahead and get started. Before we jump into that, let me go ahead and introduce myself. Okay, let me just pull the notepad and introduce myself. Okay, I'm sorry, 1 minute. Okay, so hi all, this is Shiva. I have total 10 plus years of experience in IT. Okay, out of that, I worked as a Java developer. Then I quite some time I worked as a mainframe developer. Then currently I'm working as a data analytics. Okay, and I'm working at the big data Hadoop developer. Okay, so from last 4+ years. Okay, apart from this, I do have a classroom training experience. Okay, and as well as online training experience. In the classroom, I have trained more than 1,000 people. Okay, 1,000 people I've already trained within my organization, and the online this batch is going to be the 28th batch as the online batch for me. Okay, so apart from that, I do take some of the assignments whenever I get the free time where I can help others as a freelancing kind of thing. Okay, and and I'm working currently for one of the biggest organization within India. So it's one of the leading company. So I don't have to name that one. Okay, so anything do you want me to know about from my side? Well, let me just
No,
increase.
sir.
Okay, thank you. Let's go ahead and get started. So thanks for joining, and let's go ahead and jump into the Hadoop demonstration today. Let's go ahead and briefly just discuss what is data, then what is big data, then how much data that we have currently in our market, then what are the issues that we are started talking about the big data. All of a sudden we started talking about the big data from last 4 or 5 years. Earlier there was no situation like, oh, just big data means just data is normal data. Then why we have to talk about all of a sudden the big data? Then what and all technologies that we have to address the big data related issues? Then why we have to go with Hadoop only? Okay, and why not other technologies? Then what are the advantages that we are going to see out of Hadoop? Then what are the courses that we are going to learn out of this training? Okay, and then we are going to see the end question and answers. That does not mean that you should wait till end of the course, and you can always ask me whenever you have any questions. Let's go ahead and define what is data set actually. It's a collection of related information that is called data set. Okay, that is a simple definition that we can give for the data set. So how we are going to measure that? Measuring the data set is very simple. How we are going to measure the data sets? In bytes, kilobytes, right? Then megabytes, then gigabytes, then terabytes. So far we know this one. So our so far whatever we have seen the issues, we are able to see this one till terabytes of data with our hard drives and all. So now after that, petabytes came into the picture, exabytes came into the picture, zettabyte came into the picture, and also the yottabyte came into the picture. So this is how we are going to measure the our data. So if you are talking about what is the your data set size, it's one among these things. So now let's go ahead and see how, or probably we cannot say that, okay, if you are reaching this position, we cannot go ahead and say this one, this is a big data set. It's like large data. We cannot say this is a big data which is not able to process anything or something like. Just think like this is a big data. Okay, so then what are the issues or why we are not able to process using the existing computational techniques? When I say existing computational techniques, okay, when I say existing computational techniques, okay, it can be Java. Okay, it can be Java or .NET or mainframes or any ETL related tools, whatever you take this one. So why we are not able to address when we are seeing this much of data? Okay, so this data we are getting every day from different sources. As you know, earlier back in 10 years back, we used to have that our hard drive will be in terms of GB. Okay, now it became in terms of terabytes. Now it's moving on to the petabytes. So as you know, every day we are processing more and more and more and data. So there is no way we can stop the data. Then what is the issues that we have currently with this existing technique? So let's go ahead and define the big data now. So what is big data? It's a data set. Okay, it is a data set. It's a normal data set which is impractical. Okay, I'm saying is impractical to process, impractical to store first, or and to process using this existing algorithms. So whatever algorithms or techniques, whatever we are calling, we are not able to use them to store the data or to process. It is impractical. When I say it is impractical, it is possible. It's not impossible. It's a impractical. When I say impractical, in the sense, it is not like we are not getting the results on time. That is what exactly we can say. By the time you process the data, we are getting a lot of the data and we are not able to give our reports on time on top of our big data. That is called impractical. Then why we are talking about this one? Why, I mean, really are we seeing this much of data? Let's go ahead and see from where and all we are going to get the data. Let's go ahead and define the big data using some of the 4Vs actually. Okay, using 4Vs, we can define our big data. The first one is volume of data, okay, and velocity of data, okay. The third one is variety of data, and the fourth one is veracity of data. Okay, using these four characteristics, we can go ahead and define the big data. Let's go ahead and see the definition of the volume of the data. The amount of data that we are going to add to the warehouse or destination, both are same, to the warehouse from data source. We'll be calling this one as a volume of data. It can be, example, it can be 100 bytes or 100 GB or 100 terabytes, whatever it is. The amount of data that we are trying to add from your data sources into your warehouse will be called as a volume of data. Okay, the next thing here is velocity. So what I mean by velocity? Velocity of data is something like, so you are trying to add this amount of data, whatever amount of data that you are trying to add from source to destination, at what speed? Okay, at what speed? Okay, which means are you trying to add this within a week, in a week, or in a monthly, or in a year? So at what speed you are trying to add this much of data to from your data sources to the warehouse? We'll be calling this one as a velocity of data. So this is the second definition that we can give for our data. So the last third one here is variety of data. What I mean by variety of data here? Variety of data means, as you know, if you take any data in this world, we can summarize or we can categorize that into three ways: structured one, unstructured, semi-structured. Okay, we know that. What is the structured one? If you take anything, when your data is organized in a rows and columns. The best example here is probably if you take any RDBMS related database, or if you take any Excel kind of thing. So your data is organized in the rows and columns. That is the reason we are calling that one as a structured data. Then what I mean by unstructured data? Text files, audio files, video files. So these all are like your basic example for the same unstructured data. Then what is the last one? Semi-structured. We half way only we organize the data, half of the way again it's kind of unstructured data. The best example is uh, XML files, okay, and also the JSON files or clickstream data, which means like whenever you go and access any website, they are going to access, or they are going to capture our activity. That is called clickstream data. For example, the Amazon, if you are going to just accessing their site, obviously we are going to capture, or they are going to capture each and everything that we are going to do on their site. This is called clickstream data. So any data set or any data that you are going to take, that should be one among these categories. So now, earlier we used to get only the structured data, some of the only very less unstructured data, but nowadays we are getting more unstructured data, very less structured data out of our data sources. So that is the reason. Let's go ahead and define from the beginning, and the last one is, let's go ahead and define the last one, the veracity. What I mean by veracity here is, out of this 100 terabytes of data, the valid data for me, valid data is only probably 1 terabyte. Okay, for my data analytics, this only 1 terabyte is valid data. So I need to extract out of 100 terabytes of data, 1 terabyte of data I need to extract. This one we will be calling this one as a veracity. Okay, out of existing raw data, which one is valid, you have to extract. The best example, if you're taking any banking sector, probably you want to extract only the transaction related data out of your entire data. So in that case, I mean, for other purpose I might be using this transaction data. That does not mean that I'm not going to ignore that 99 remaining 99 terabytes of data. No, I might be using that one for my either data analytics purpose, but for the main purpose that I'm going to do here is this data, transaction data, which is only valid 1 terabyte. So extracting the valid data out of your raw data is called veracity of data. So now, if your data set is having high in volume, high in velocity, high in variety, and high in veracity, if this data set is having these characteristics, that time we will be calling this one as a big data. Okay, this is the purely IBM definition. This is one of the interview question, and also then the certification you will be asked. Any questions here? So how we can define the big data using some of the V's? These are the volume, variety, volume, velocity, variety, and also the veracity. Any questions?
No, sir.
Okay, perfect. So now, are we really getting this much of data from our different sources? Let's go ahead and see that one. Okay, so the best here, you can see here, volume, volume, velocity, variety, and veracity. And you can see here, from these are the sources where data is getting generated and added to the data warehouse. You can see within 60 seconds of time, this much of data we are adding to our warehouse. So this speaks about really whatever we discussed about volume, velocity, variety, and veracity also. You can see here, YouTube, if you take example, I'm sorry. So this is within 60 seconds of time, 600 plus new. Sorry. So within 60 seconds of time, okay. So I'm trying to add this much of data. You can see 600 plus new videos are getting added from the YouTube, and how many new images are getting added to the Flickr. Okay, how many voice calls are happening within 60 seconds of time. So this is clearly talks about how much data from different sources we are trying to add to the warehouse. Okay, so this is called 4 V's actually. So there is no way we can stop generating the data here. Okay, that is the reason we have two issues with our existing computational techniques. As you know, with this picture, the storage, right? There are two issues. Currently, two issues we have with current existing algorithms. Okay, what are they? One is storage wise. We know that we are getting this much of data from different data sources. That is the reason we are not able to process. The next thing here is processing. Okay, so that's what we said. It is impractical to store and to process with the existing computational techniques. That is called, we given the first definition of big data. So by seeing this picture, you can see very clearly this much of data is getting generated within 1 minute of time. That is really speaks about how much data that we are getting and why we are not enough capable to store the data using existing computational techniques, and why we are not able to process the data on time. By the time you process the data, we are seeing lot of additional data coming into our warehouse. That is the reason our existing systems are failing to do this one. They are straining to process this data, to store the data. Okay, that is exactly that issue that we have with our big data. So now, how we are going to address these big data related issues? So for till certain extent, we can go with the SQL, or we can go with the probably Teradata, and we can have HANA, and we can have Hadoop, we can have some NoSQL databases. So all these things are laid way to address to address big data related things. Okay, so to address the big data related thing, these are the two ways where we can see that one. So all these are like, we are going to see the features of this one Hadoop, then we can discuss why can't we use other things, why only we have to go with Hadoop. That's what we are going to see. So then the first and foremost definition, what is Hadoop? Okay, Hadoop is a open source framework. What I mean by open source framework, when you say framework, mostly 70 to 80% of work will be done by the framework, and remaining only 20-25% of the work has to be customized and placed into this one, that as per our requirement. This is Hadoop is a open source framework, okay, and written in Java, okay, on Linux OS, okay, which is intended to address the big data related, mainly big data related issues in terms of storage wise and in terms of processing wise. Okay, we'll be calling this one as a Hadoop. That is the first definition that we can give for the Hadoop. It's an open source framework which is written in completely in Java. That does not mean that we have to know completely Java in order to learn this one. No, we are going to see one by one. So why we have to go with the Hadoop when you have Hadoop kind of technologies? I have listed some of the features from the Hadoop. Let's go ahead and see that one. Okay, the first and foremost thing here is you can collect the data from different sources. It can collect the data from satellite, it can collect the data from sensor data. The first feature is collecting the data from different sources. Okay, it can collect the data from satellite. Okay, it can collect the data from sensor data. It can collect the data from GPS, whatever some devices are generating the data every day, they can go ahead and connect to that, and they can get, and content management, different servers we can connect the data, or probably telecom data. Probably you can connect to the different centers and they can collect the data. So this all from using your Hadoop, you can just simply connect to your data sources and you can collect the data, it can capture the data, it can import the data into our Hadoop framework. Okay, that is the features of this one. So now the next thing here is the scalable. I mean, we have some other features, but we are going to see very important thing, scalable one. What I mean by scalable, how much, if you need, client wanted more storage capacity, just go ahead and add machines. How many machines that you can add? How many machines that I want, I can go ahead and add. If I want to add probably 100 machines, go ahead and add to the systems that are 100 machines. 150, 200, 1000, that is called scalable. We are going to see how it is possible within our Hadoop framework. And this third one here is, it can store the data in a commodity hardwares. Okay, what I mean by commodity hardwares here is there's a cheap hardwares. Okay, cheap hardwares in the sense they may go down anytime. So we are saying here is a cheap hardwares, then now we are going to rectify this one. So before that, what is the difference between the commodity hardwares and enterprise hardwares? So enterprise hardwares are high reliable hardwares, Okay, what I mean by that one here is they may not go down anytime. These are the low reliable hardware. Commodity hardwares are the low reliable hardware. They may go down anytime. So obviously, whenever you are going to use any Java, .NET or mainframes related thing in the production environment, we have to use the enterprise hardwares because we need to keep our systems up and running. But we are saying with our Hadoop, we can go ahead and use the commodity hardware. The difference here is if you want to buy 1 terabyte of hard drive, you have to spend at least 1 terabyte of hard drive, you have to spend $5,000. Okay, whereas if you are going with this one, if you want to buy 1 terabyte of hard drive, as you know, whatever we are using in our systems on our personal laptops, including the Mac, there's a cheap hardware, commodity hardware. They are just, instead of just spending $5,000, you can spend only $100. So for this reason only, Hadoop became very famous. Okay, these are very cheap in maintenance actually. So now how we are going to maintain that one? So that is that feature. Whenever your systems, you are saying that it is like there is a fault because it's saying a low reliable hardware, they may go down anytime. Then how we are going to recover the data? Using the fault tolerant. Okay, using the fault tolerance, using fault tolerance, we are going to address this issue. So using the replication factor. What I mean by replication factor is at the time of storing the data, instead of storing the data in one machine, I'm going to store into multiple machines. So if one of the machine is going down, the other machines will come into the picture and act as a that machine. Okay, so that is the replication factor. So okay, already we are talking about the big data. Then if you are going to have a multiple copies in your this thing system, then how you are going to maintain? Yes, how many systems that you want, you can add with this feature. Okay, there is no for our Yahoo, Google or something, these kind of organizations adding just these kind of computers, it's very cheap for them adding this kind of computer, because for just buying one computer you can go ahead and add how many computers you can have? 50 computers you can add. So that is the power. So that is the reason we can go ahead and include the, how many machines that we want, we can go ahead and add, including with the features of the scalability. So that is the reason we are going to use this fault tolerant. Using the fault tolerant, which means by having the more than one copy within our system, we are going to address these commodity issues. So by having this, all these features together, if you want to go with other softwares kind of Teradata and all, we are not able to get all these features together. That is the reason we have to go with Hadoop when you have Hadoop kind of technologies in the market to address the big data related issues. Okay, any questions now? If you don't have any questions, I will move forward. So we are going to see the Hadoop architecture. So Hadoop is going to work with two main core components. Okay, one is HDFS, Hadoop distributed file system, and the second one is MapReduce. What I mean by this one, these two, let's go ahead and draw a small picture and I'm going to explain this one. Hadoop is going to work, first of all, master slave architecture, which means we are going to have a cluster. Cluster means a group of machine. If you are putting together more than one computer together, that time we will be calling this one as a cluster. So they all are interlinked together. I'm going to show you how the cluster is going to be at the end. Okay, so now you can see here all machines are put together here. They are all linked, interlinked together with high reliable cables. And one, this is all our machines. You can see whatever boxes you are seeing, these are machines. One machine is acting as a master computer, other machines are working as a slave machines or worker machines. Okay, worker machine 1, worker machine 2, okay, worker machine 3, and worker machine probably 100, whatever, how many machines that you want, I can go ahead and add here. So now you can see this is called master slave architecture. Okay, masters to slave architecture. Okay, our Hadoop framework is going to work as a master slave architecture. So here, for example, I am getting one data set temp.txt file which is having 4 terabytes of data. Okay, so now instead of going and storing these 4 terabytes of data in a single machine, what I'm going to do here is I'm going to cut down this one into chunks of data. Okay, so I'm going to divide that one into more than one part. So that part only we are calling here as a block size. The amount of data that we are going to cut down is called block size. So now, for example, I have divided this one, two, three, four blocks here. So for example, that request will send to the master node. Master node is the one who is going to divide that my entire file into number of blocks or number of chunks of data. We as a developer don't have to write the separate logic for that. So for example, 1 TB I have stored here, one more terabyte here, one more terabyte here, and one more terabyte probably in a 100 computer. It does not mean that all you have to store one by one. It can be stored anywhere. So now we have distributed easily whatever data that we are getting from the different sources here. What we did, we just distributed the data into multiple computers. How much data that you want, you can now accept that one using this concept, because I'm going to end of the day, I'm going to divide my entire data, I'm going to store into the multiple computers. So this concept only we'll be calling as a Hadoop distributed file system. Okay, so we are going to see the history and all when we start our first class, how this Hadoop came into the picture. But as of now, distributing your data into more than one computer by dividing your entire data into chunks of data will be called a Hadoop distributed file system. The next thing here is the processing. So we are able to address the storage was issue, whatever we have out of our big data. Then the processing wise, for example, this is my machine and I have stored the 4 TB of data in a single machine. Okay, just to go ahead with the normal existing algorithm, and actually I'm going to write some logic here. That logic is going to work on top of this one. So obviously this machine has to work on top of this 4 TB of data and giving the results back to this one. In this same case here also, I'm going to write the logic to process my 4 TB of data, and I'm going to send that request to my mainframe, my master. So now here I don't care about how it is going to process. That will be taken care by my framework. That is the reason Hadoop is a framework, which means 70 to 80% of the work is going to take care from us for us. Okay, so now this logic will be sent to my master. Now master is the one who is going to send the same task to individual computers here, to individual computers wherever my data, this temp.txt file exists. That for each and every chunk I am going to send this logic. Okay, I'm going to send this. How we are going to send, I don't care about that one. My master is going to take care of that. My framework is going to take care of that one. So now this computer is going to have, or this computer is going to take care of only 1 TB of data. Here 4 TB of data one machine has to take care, but here one machine has to take care of only 1 TB of data. How much we reduced? 1/4 of work we reduced for our single computer. The same way here, the same way here, the same way here. So once they do that, as they know, once they find out whatever the logic that you are going to write here, and they are going to send the results back to the master. Now master is the one who has to consolidate the final results all together, because this is not my final results. So here master is the master is the responsible for just consolidating the final results and give the final output accordingly. Okay, so this is how will be, how you are giving the request back, the output back to your client. The same way this output will be given back to the client. This is what exactly is going to happen in our master slave architecture, especially in our Hadoop. So this processing echo component, whatever we are talking here, we have to write in some language that is called MapReduce. It's a programming language using which we can process the large data sets whatever we stored in our HDFS file system. Okay, so we addressed, so here you can see very clearly my data is not moving where my code resides. Generally here in this case your data will be moved where your code resides here. Probably your application server is here somewhere else here, and you are going to, your data is going to be moved here and running here and sending the results back to here again. But here my code is coming where my data resides. Okay, exactly, this is called your code locality and this is called your data locality. Your code is coming where data resides. That is the reason our big data, our Hadoop is going to take very less time, even though you are processing the large amount of data, terabytes of data also, it is going to take the less amount of time. So now what we said here is the scalable. So now if I want more machines, I can just go ahead and add the computers. If I want the more storage capacity, I can go ahead and add. If I want more processing capacity, I can just go ahead and add more systems to the cluster. This will be calling this one as a cluster. What is the cluster? Group of machines, if we are putting together within the network, that time we'll be calling this one as a cluster. Okay, so these are the two main core components that we are going to see out of our Hadoop. Any questions so far?
No, sir.
Okay, perfect. And let's go ahead and see what and all we are going to cover in our courses actually. In the course, we are going to cover HDFS completely, MapReduce. Okay, these are the two core components which we are going to cover. These are the core components of our Hadoop. We are going to see completely this one. Plus the next, as you know, whenever you are going to have the MapReduce program, at least you have to know some programming techniques, basic Java or C++ or Python or probably any programming techniques that we are going to have. But I don't know anything about Java, I don't know anything about the Python. That is exactly, that is the issue that we have in our currently in our market. That is the reason they developed some more products called pig. Pig is a alternative abstraction on top of MapReduce. Okay, so which means I don't have to know anything about the Java. I can go ahead and just have the pig Latin scripting language. Pig is going to use pig Latin scripting language. It's a scripting language. It is very simple. It does not you don't have to think like it is a like a VB scripting and all. It's very simple language using which we are going to write without knowing the Java knowledge. Also we can go ahead and write the pig scripting, and that will be converted into series of MapReduce programs. Who is going to take care of that one? So for example, 4 lines I have written as a script. These 4 lines will be converted. So who is going to convert that one? My framework is going to convert it into MapReduce programs. Okay, so I don't care about how it's going to convert, but in the back end, this will be converted into series of MapReduce programs. That MapReduce program is going to work on top of my data whatever I stored in the HDFS file system. So that is the reason pig came into the picture. We are going to see very thoroughly pig and pig UDFs also we are going to see. These are advanced concepts that we are going to see out of our use. UDF means user defined functions. So we'll be having some functions within our pig, and built-in functions will be there, where like along with our pig software we are going to see some built-in functions, but using them, if you're not able to accommodate or if you're not able to address your issue from your organization, you can go ahead and have your own functions that is called user defined functions. We are going to see very thoroughly these user defined functions in our pig. So the next thing is, I don't want to learn anything. I know already some of the SQL knowledge. Then in that case, we can go ahead and have the Hive. Hive is the same as MySQL. Okay, it is a high structured query language. Okay, high query language you will be calling as a HQL. So we are going to write our queries in a high QL. Okay, HQL means high query language, and we are going to convert the same thing. How these will be converted into the MapReduce program? The same way these queries will be converted into series of MapReduce program by our framework. We are not going to care about how it is going to be, but this will be converted into the series of MapReduce programs. So that also will be taken care of that one. And also we are going to see how different tables. Okay, so we'll be having the managed tables and external table. We are going to see very thoroughly what are these tables and how we are going to take care of this one. Okay, and we are going to cover this one, and partitions we are going to cover, and also the buckets are the next concept that we are going to cover, and the Hive UDFs also we are going to cover. It's the same as user defined function. Hive and pig are going to be executed in the same way. Pig is developed by Yahoo and Hive is developed by the Facebook. They are going to be exactly the same way. The main intention of developing these two is people who are having the Java or any programming language are very less in the market to write your MapReduce program. That is the reason they came up with these two components. Clear? This is what we are going to cover. Plus on top of this one, we are going to see HBase. HBase is a NoSQL database. It's a columnar database. Okay, what I mean by columnar database here is you're going to store your data in a column oriented way. Whereas if you're going with a MySQL kind of thing, we are going to store the data in terms of rows and columns, right? Here we are going to have only single column where it can accommodate even billions of records, not million. MySQL can accommodate only millions, but here billions of records can be captured within this NoSQL database. This is called HBase. So we are going to see very thoroughly about the HBase also. The next thing here is, the next thing that we are going to cover is Scoop. Okay, so as you know, my current organization is already using MySQL. Okay, and I would like to transfer the data. MySQL is not able to, is not enough capable to process the data. In this case, we are going to, this is an import tool. We are going to import the data from RDBMS databases to Hadoop. Okay, we are going to connect lively from different RDBMS data sources into Hadoop, and we are going to import the data into our Hadoop framework. That is what we are going to see. And also back, you can export the data to RDBMS. Okay, or MySQL, whatever it is. Okay, we are going to import and export the data using your Scoop. Scoop is SQL to Hadoop. Okay, this is a ETL tool. It is a ETL tool. Okay, we are going to see very thoroughly this one. And one more ETL tool that we are going to see is Flume. Flume is also is a ETL tool using which we can import the streaming data actually. So we are going to see very thoroughly about these things also. Then after that, we are going to see Oozie. Oozie is the scheduler. Okay, is a scheduler. We are going to see very thoroughly how we are going to schedule more than one job within our production environment. We are going to see very thoroughly about the Oozie also. Then we are going to see the Zookeeper. Okay, Zookeeper is a cluster coordinator using which we are going to coordinate our entire Hadoop cluster between this one and between your client and parallel processing. We are going to see that one also. These are all we are going to see very thoroughly. Along with this one, this is completely Hadoop course. Actually, we are going to get this kind of package. On top of this one, we are going to discuss the advanced concepts from the Hadoop also, that is called Spark. Okay, in the Spark we are going to cover Spark core and Spark streaming. Okay, these are the advanced courses we are going to cover very thoroughly. And as you know, in order to develop your Spark application, we need the Scala. It's a functional programming language. Okay, we are going to see very thoroughly about the Scala and a required skill set to start, to develop Spark application. We are going to see very thoroughly using in our classes. The next thing here is, as you know, we have seen Spark, we have seen Spark streaming, we have seen Scala also, and we are going to see how to connect Hadoop to Spark. We are going to see that one. Okay, and we are going to see how to run the Spark application using your HDFS file system. We have distributed the data. Spark is not a storage component. Okay, process is not the programming. It just only is going to the process our data using our RAM. We are going to see very thoroughly how the Spark is going to work on top of your HDFS file system. We are going to see very thoroughly. On top of this one, as you know, Hadoop is not a reporting tool. Generally, end of the day, all your IT guys are going to work for the report actually. So in order to create the report, we have to have some BI tools actually. So out of the existing available tools in the market, Tableau is the best one. So using your Tableau, we can create, or we can visualize your data in terms of seeing in a rows and columns. You can visualize the data in terms of graphs and all. And we are going to see Hadoop. We are going to see here Tableau installation. Along with that, connecting Hadoop to Tableau lively, especially here Hive. Okay, we are going to connect to Hive databases, Hive warehouse directly using your Tableau. So we are going to see the Tableau, how to install the Tableau, what are the different graphs are available in our Tableau, and what are the different markers are available in our Tableau, and how we are going to use them, and how we are going to create the sheets, and how we are going to create the worksheets and workbooks and dashboards and all. We are going to see very thoroughly using our Tableau in our training. Then this is all we are going to see very thoroughly in our classes. Apart from this, we are going to cover the certification related things also. If you are planning to take the certification, we are going to cover thoroughly about Cloudera or Artenwork certification related things, which we are going to cover. If you need any help in that one, I'm going to cover for them because I'm a Hadoop Cloudera certified also. Okay, so if you want any help in that one, I'm going to help you on that one also. Plus, we are going to cover admin related things also. Okay, Hadoop admin related things especially. Okay, so what I mean by that one here is I'm going to teach you first single node cluster installation. Okay, multi-node cluster installation, which means I'm going to have more than one machine together. I'm going to show you how to do the multi-node cluster installation. Okay, so now plain from scratch onwards, how we are going to have the operating system, on top of that installing the Java, installing the Hadoop framework, then how we are going to partition your name node, then how we can do all these things we are going to see very thoroughly in our thing, and some of the configuration related settings, which means how to edit the some of the configuration files within your Hadoop. So it can be some of the HDFS related, it can be some of the map related things. We are going to see very thoroughly in that one. And also these are and also all ecosystems installations. Also we are going to see. What I mean by that one here is Pig, Hive, HBase, Scoop, Flume, and Uzi. Okay, we are going to see the installations of all these ecosystems also in my training parts. Okay, this is what our admin is going to cover. Our admin related things are going to be covered in 30 to 40% in our classes. Okay, so and also on top of this one, for your interview purpose, I'm going to help you out resume preparation. And also I'm going to give you some of the interview questions. I'm going to guide you how to face the interviews and interview questions related things also. I'm preparing already. I'll keep on update the interview questions. I'm going to give it that you. I will go through the interview questions after we are done with our training, and I will let you know where we are, and if you have any tricky questions we are going to discuss very thoroughly in this one also. Okay, and also the certification guidance also. Certifications related things also we are going to cover. I mean the topics that we are going to cover, the material that I'm going to provide to you is going to cover 100%. It's going to help you out the certification related things also. That's how my students have achieved the certification. The same way it's going to help you out for you also. If you're interested more personally, I can go ahead and help you out in taking out the certifications also in this one. Okay, so these are all about the training that we are going to discuss, and these are the things that we are going to cover within our Hadoop course. If you have any questions, please go ahead now.
No, sir.
Okay, so we are going to see at the end, we are going to see some small thing here, how the Hadoop cluster will be. You can see here, this is what the Yahoo cluster. So this means you put all machines together within the rack and it's going to connect each other. So in our Yahoo, currently 45,000 machines are together, they are kept and they're running as a cluster here. So here exactly what we are going to do here is we are going to use our softwares and we are going to put all our machines together. These are the machines. So okay, I'm going to put all these machines together. I'm going to make it as a multi-node machines, multi-node cluster actually. So you might be wondering, I don't have any machines, how I'm going to make the multi-node cluster. So you don't have to have the machines. All we are going to create the virtual machines and we are going to connect all that virtual machines together using your host computer only. This is called multi-node cluster. So we are going to see very thoroughly how we can keep that more than one computer together, and how we can, when you are going to place any data set within your multi-node cluster, your data will be divided in terms of blocks and each block will be stored in a different computer, which we are going to see very thoroughly in our classes. Okay, so any questions so far, whatever we discussed?
No.
Okay. Okay, then that's all we have from our end, and thank you so much for attending this class. Okay, see you soon again. Just be in touch with your
Thanks.
organizer and we are going to start the class at any moment. Okay, thank you so much. Bye.
Okay. Okay, thank you, sir.